Hi everyone, I'm Selena, an informatics major at UMass Amherst. This summer I interned at High Dive Lab in the Department of Biomedical Informatics at Harvard Medical School, where I worked on creating a Python package called EasyVitest for interactive single-cell visualizations. For some background, ScanPy and Spatial Data are Python libraries that support visualizations for single-cell data. Vitest does something similar, except the visualizations are interactive. Here's an example from their website. You can find some more examples on the website. Vitesse can handle transcriptomics, proteomics, and spatial data. You might have seen it on the HuBMAPs tool page, which I've shown in a screenshot on the right. It can be used in Python and R, and for my project, I focus on the Python part. Some other things I used for my project were GitHub and Jupyter Notebook. GitHub is a platform to store, manage, and share code. Um, GitHub repositories are storage systems designed to manage code, and I also use GitHub API, which can retrieve data for GitHub. I did most of my coding in Jupyter Notebook, which is a web-based development environment that can display graphs and images. Currently, using Vitess requires some setup by the user. The objective of my project is to abstract this away from the user, so that 30-something lines of code turned into 2 to 5 lines. For this package, all interactive Vitess plots are enabled by default upon installing it. To disable them, the user can pass the disable plots argument into the plots they want to deactivate into the function configure plots, which can be imported from the package. The same can be done to re-enable them again, except the argument enable plots will be used instead. As mentioned previously, the goal is to create a Python package that makes using Vitess more streamlined so that data analysts can view interactive plots within their existing workflows with minimal code changes. To achieve this, the timeline was broken up into roughly 3 parts. Part 1 was understanding which plotting functions from ScanPy are most commonly used. This was done through a code search on GitHub. Part 2 is the bulk of the coding portion, where I overrode existing ScanPy spatial data plotting functions through monkey patching. Monkey patching changes the behavior of a function without changing the underlying code, sort of like writing your own recipe and stapling it on top of the old recipe. Part 3 is finalizing the project and it's where I am currently. This includes creating a Python package and pushing it to GitHub, refining the package, and setting up a documentation page. For part 1, the code search, I use a Python function utilizing GitHub API to search repositories that use ScanPy in their code. The reason for determining the most commonly used plotting libraries, such as PCA library or heat maps and so on, is to figure out which plots are supported by Vitess and decide which plots to include in the package first. This gave my project timeline some structure rather than trying to add everything in at once. For part 2, coding the package, it involved using monkey patching for overriding ScanPy functions. The reason for monkey patching is so that the library has similar syntax to ScanPy. I also overrode spatial data plotting functions, except I wrote a new Python class rather than monkey patching. However, with both methods, the user won't need to make any drastic changes to their existing code. So, why use 2 different approaches when they have similar functionalities? It's because the way you use ScanPy and spatial data are different. For ScanPy, all arguments are passed into the plotting function, as shown here. Thus, only the function, which in this case is spatial, needs to be monkey patched. For spatial data, arguments are passed into functions, which are then chained together, which you can see here. This requires a class. Before showing some examples of EasyVitess's usage, here are what static plots from ScanPy spatial data look like. The top left over here is spatial data, and the remaining 2 are from ScanPy. Here are the corresponding examples for EasyVitess. You can see the code on the top of the video. The spatial plot requires a little bit more setup than the others, but still relatively similar to spatial data syntax. On the right, there's a gene list so that you can select which genes you want to look at, and then change the opacity of the image and spots. And here's a dot plot, which you can select which cell types displayed on the bottom here and on the bottom right. And then you can select more genes if you like. And then lastly, one of the dimensionality reduction scatter plots, HuBMAP. Here I'm adjusting the radius of each of the spots. For part 3, finalizing the project, I've already uploaded the package to GitHub. Here's a README file, which shows how to install the package over here, and some information about its functionality, such as types of plots it can create. I'm still working on refining the package, uh, such as adding more customization options for the user. I'm also working on a documentation page. An early version of it looks like this. The landing page has installation and import instructions as well as example code. It's pretty similar to the README file, except it goes into a little more detail. This next page lists out everything that can be passed into each function. So for the function render shapes under the class Vitesse spatial data, you could pass in these three elements. For the next steps, I plan on receiving feedback from additional sources such as SE versus Zulip forum, publicizing Easy Vitesse through an academic paper, and potentially adding testing. To conclude, I learned a lot about various tools that could be used to visualize single cell data and working with code that didn't write and integrating it into a package. For Python specific things, I learned more about libraries and packages that I haven't used before, such as AndData, a bunch of coding life hacks, and how to auto-generate code documentation. I've also learned how to upload and manage a repository, which involves committing, pushing, and pulling code. Finally, I'd like to thank my mentors Mark, Tabasa, and Lisa for being super helpful and supportive throughout the whole internship, my PI, Dr. Nils Gellenberg, for giving valuable feedback every week, all the High Dive Lab members for creating a fun and welcoming environment throughout the whole summer, and HuBMAP at NIH for this opportunity. Questions?
Selene, thank you for a nice presentation. So I'm curious, and this is a question also for everybody else, every one of the students who wrote code. Do you guys use ChatGPT to help you write code?
I tend to try to stay away from it just because I want to have a stronger foundation for future coding assignments.
Okay, thank you.
If anyone else wants to answer as well, they're more than welcome to. All right. Well, Selena, I'll ask you one quick question, similar to Sam. What would you say was the biggest takeaway from doing this course?
Biggest takeaway. I guess it's that. Sorry, was you're saying?
No, just what would you use in the future? Sorry.
Oh, what do I use in the future? I learned a lot more about like coding using Python, things that I wouldn't have thought about doing before. Like as example, there's something called list comprehensions in Python, and I've hardly ever used it, and then this internship kind of taught me how to use it in other contexts.
Awesome. All right. Well, thank you so much.